Okay. Good morning to the last Math Teas workshop for this semester. If you have any questions, you can always contact me. So after you take the practice teas or right before the practice teas, if you find anything that you're not sure of, you can always email it to me. I can write you the answer, take a picture, and send it back to you. Okay. Now, let's do some a little more basic stuff. What I tried to do was go over a lot of stuff that um, people normally get wrong. Percent word problems, translation word problems, a lot of vocabulary such as statistics and rate of change. What I'm going to do now is just go do the down and dirty pre-algebra that usually shows up, and I just want to make sure that you're comfortable with it. Okay, so let's first do the linear algebra. So let's make sure we can do something like this. Let's make sure we can do something like this. Let's solve this. Okay, now the key for these problems is that we want x's on one side and numbers on the other. We don't care which side the x's are on, which sides the numbers are on. We just want them on separate sides. So the first thing you want to do is I can either get rid of this 2x or I can get rid of this 12. I'll do this. Now, there are a lot of ways to do it. You may have been taught a different way. And if you want to use that, that's perfectly fine. Okay. Now, the key thing is this, is that if you get rid of x's on one side, right, you have to get rid of numbers on the other side. That way you end up with x's on one side and then numbers isolated on the other side. And then let's simplify. Sorry about that. Okay, and remember to simplify your answer at the end if you can. So let me give everyone a second to copy. Now, alternatively, some students have been taught to solve this problem a different way. And then for those of you who forgot, let me just sort of remind you, and then I'll give you one to try on your own. What some students were taught, a lot of times students who were educated under the Soviet education system. So not just if you're from Russia, but if you're from one of the countries that Russia used to have influence over, El Salvador, Venezuela, Armenia. What they were taught oftentimes is bring all the x's to the left, and when I bring this to the other side, I use the opposite side, right? So, and then when I over here, I have the -4 left over, and when I bring the 8 over to that side, again, I use the opposite side. Now you'll get the same answer. you'll get minus 10x is equal to minus 12. And then you'll divide both sides by minus 10. And then you'll get x is equal to 6/5. So remember that negative divided by negative is a positive number. Okay, so let me give you time to copy that, and then I'm going to give you a problem to try. So let's try this. So I'm going to use this first method, but you could easily just use this method. So I'm going to subtract, I'll just subtract 9x from both sides. Now, once you get rid of variables on one side, you have to get rid of numbers on the other side. Okay. Now, notice that we're using the opposite sign. Since that's positive, to get rid of it, we subtract it. Okay. Since that's negative, to get rid of it, we add. So now I have negative 6x is equal to 13. And we can divide both sides by negative 6. Okay. Let's take a picture. Now, we're going to change it up a little bit. In this one, we had 1, 2, 3, 4 terms. Terms are separated by plus or minus. Okay. So now the question is, how do I solve this if I only have 3 terms? So for example, if I had something like this, make this 9. So now I have only 1, 2, 3 terms. Now, what you want to do is that if this is a number, right, just a constant, I'm sorry, this right here. So if this is a constant, you want to get rid of the constant. So you want to subtract 4, subtract 4. Give everyone a chance to copy. And remember, if you have any questions, just interrupt me at any time. Now, let's contrast this, right? So at this point over here, this was a constant, so we got rid of the constant. The reason why is that we wanted variables on one side and numbers on the other. So when I get rid of this, that's what we have. Variables on one side and numbers on the other. Now, let me contrast that with something that looks like this. Oh. Okay. Now, instead of having a constant out here, I now have a variable. So if we have a variable, what we want to do is get rid of the variable on this side. So what I'm going to do is I'm going to subtract 3x from both sides. And I get 4 is equal to minus 12x. And then I'm going to divide both sides by minus 12. And then we get x is equal to minus 1/3 like that. So go ahead and copy that. Okay. Now, usually at this point, a class that's a little less shy will ask me a question about this part over here. And they'll go, hey, Dr. Kawhi, you have that negative on the bottom, but when you write your answer, how come it's in the middle? Why does it stay in the bottom? And the same could be said over here. Dr. Kawhi, is that negative supposed to be on the top or the bottom or in the middle? Now, talk about that a little bit. We have 3 cases. Okay. So we can have the negative in the middle, the negative on the top, negative on the bottom, or negative on the top and bottom. Now, the way we would solve this problem is we would Notice that this negative is not connected to 6 over 2. It just comes down, and you go 6 divided by 2 is 3, so your answer is -3. Now, when I'm working over here, a negative divided by a positive is a negative number, and a positive divided by a negative is a negative number. So these three are equal. Right? So it doesn't matter whether the negative is on the top, the bottom, or the middle. In both this case and this case, where the negative is on the top, you could write it in the middle or on the bottom. And over here, even though it's on the bottom, you can put it in the middle. Okay? And because it's multiple choice, it shouldn't be a problem. Now, the only one that you have to be careful of is this over here, because a negative divided by a negative is a positive number. So this is the only one you can't do. If you have one negative, you can't split it into 2 places. Now that we got that small detail away, let me put up 2 problems for you to work. Okay. So remember that thing that tells you what to get rid of is this side over here. So this is a constant. So I'm going to get rid of the constant. Give you a minute to try that one. So this one is a variable. So that tells me to get rid of the variable. And I'm going to get rid of this -11. And a negative divided by a negative is a positive value. Okay. So let's go a little more intense. So let's do something that looks like this. Solve 2x plus 3 . All right, that looks reasonably terrible. Now, when you want to attack these problems, when you have these parentheses, the first thing you want to do is you want to distribute. So go ahead and distribute. Multiply 2 with that, 2 with this, 5 with that, 5 with this. Let's distribute that. So I have 2x plus 6, 5x. Now, the next thing we do is we want to combine like terms. So what we want to do is we want to combine the x's with the x's and the numbers with the numbers. But remember, when you combine like terms, you do not combine across an equal sign. So over here, you're just going to combine the 6 and the -4. And over here, you're just going to combine the 5x and the -9x. You don't cross the equal sign. Okay. So let's see if you can do that. Just combine that one. Remember that the sign goes with the thing on the right. So now we get 2x minus 2 is equal to, is that right? 2x plus 2. Okay, 2x plus 2 is equal to minus 4x plus 10. And now what we want to do is we have the same situation that we did before. You want to get rid of x's on one side and get rid of numbers on the other. Okay, so go ahead and do that. Go do what we were doing before. Plus 4x minus 2 minus 2. So we have 6x. And then we're going to divide by 6. And then this one said something like that. Okay. So let's try another one. So I'm going to go 3. Let's try this one. Okay. So do the same thing that we did before. Go ahead and distribute. Multiply this with that, this with that. Now, when you multiply this, we're multiplying the entire negative 5 with this. And that. Now, combine like terms. Remember that when you combine like terms, we are not combining across an equals line. There's a big wall over there. Excuse me. So we're going to combine this with that, okay? And the plus 6 and the minus 20. Remember that the negative or the positive goes with the thing on the right of it. So now we get 3x plus 6, I'm sorry, minus 2x minus 14 is equal to 7. And then because this is a constant, we want to get rid of that constant. So we're going to add this 14. And we're going to get minus 2x is equal to 21. And then we're going to divide both sides by minus 2. So go ahead and copy that. And while you're copying that, I'm going to change that into my marker. Let's take a picture of this. Now, let's work on solving these linear problems with fractions. So something like 1/2 x plus 1/3 is equal to 5 over 12x minus 1. So let's copy that down. Now, well, let me give you a second to copy that down first. Now, for the TEAS exam, when they give you this linear equation problem with fractions. This typically is around the difficulty I see. I will give you a few more options of how they can give it to you, but I'd make sure that at the very least I can do this. Now, at the core, fractions are hard. So whenever you have a chance to get rid of fractions, you want to get rid of the fractions. Now, we can only use this technique because we have an equation. What an equation means is that I have something equal to something. This equal sign allows me to multiply each term by the lowest common denominator. Multiply each term by lowest common denominator. Now, if you ask me, well, what's a term? Terms are separated by plus or minus. So this is a term, this is a term, this is a term, and that's a term. Each one of those we want to multiply by whatever the lowest common denominator is of a half, a third, and 5/12. Okay, let me give everyone a chance to write that down. Okay. Now, for some of you, you'll see like, oh, the lowest common denominator is 12. For those of you who don't know how to get a lowest common denominator, one of the easiest ways is to pick the biggest number, 12. And then skip count by 12. 12, 24, 36, 48. And then you ask yourself, for the other numbers that are smaller, what is the smallest number here in this group where both 2 and 3 divide into it? In this case, it would be 12. So we want to multiply each term by 12. So I have, well, let me put it in green. 12 times 1/2 x plus 12 times 1/3 is equal to 12 times 5/12x minus 12 times 1. Okay. Let me give people a chance to copy if they copy. Now, what we want to do over here is we want to divide the lowest common denominator by the denominator. 12 divided by 2, 12 divided by 3, 12 divided by 12. Okay, so let me write that down. Divide the lowest common denominator by the denominator. So I want to divide this and this, this and this, this and this. Okay. Now notice that because we do that division, we get rid of all of our denominators. Okay. Now usually the biggest question people ask me is, do you multiply this one by the lowest common denominator also, even though it doesn't have a, it's not a fraction? And the answer is yes. Every term gets multiplied by the LCD. And now we have the problem that we had before. So go ahead and solve that. Okay. Here, bring x's to one side and bring numbers to the other.
Professor,
Yes.
how did you get the 3? 6 plus 3?
Oh, I wrote it down
Plus
wrong.
4.
You're right. Thank you very much. I appreciate
Okay, because I put 4, that's why.
it. You're correct. Thank you. So I'm going to subtract 5x on both sides. Subtract 4 on both sides. And we'll get x is equal to negative 16. And then we're done. Okay. So let's give you another one to try on by scratch. So let's go x plus 1 over 3 is equal to 2 over, let's make it 7 x. Let's solve this one. So let's think about the lowest common denominator. I'm going to skip count by the biggest number. Now, if you know how to do it in a different way, that's perfectly fine. This is a little hack, but the hack works. Okay. Now, 3 doesn't divide into 7, it doesn't divide into 14, but it does divide into 21. So we're going to multiply each term by 21. So we're going to go 21 x plus 21 times 1/3 is equal to 21 times 2 over 7, x like that. Okay. Now go ahead and do the division, right? Divide the 21 by the denominator. we're going to divide this, divide that. So we get 21x is equal, oh, sorry, plus 7 is equal to 6x. The 6 is from the 3 times 2. And then, since this is a variable, I want to get rid of this variable. Now I'm going to divide both sides by negative 15. This. Now I'd make sure that I could do both of these. I think these are the most common problems. But let me show you the two sort of ways in which they can like alter it a little bit. Okay, but let me give people time to copy. So let's erase this part. Now we're going to keep the same rules. See, notice that I didn't erase the instructions. Okay? So whenever I see fractions and an equal sign, like I'm going to do the same thing every time. So the first sort of thing that might be a little bit different is that they may give you something that looks like this. 3x plus 2 over 2 plus x is equal to, let's call it, let's make this a 4. And just to make it interesting, let's make this 1 over 6, like that. Okay. So what I'm going to do is I'm going to multiply each term by the lowest common denominator. Make sure I take a picture of this last one. Okay, I did. All right. So we're doing the same thing. We're multiplying each term by the lowest common denominator, even though this thing has something a little more complex than what we had over here, where we had a single number for our numerator. Okay, but we're just going to do the same thing. Now, 6 is my biggest number. I'm going to skip count by 6. And the first number that 4 divides into is 12. So I'm going to multiply each one of these by 12. I'm going to have 12 times 3 plus 12 times 1 time to copy. Okay, now let's remember what the command is. Divide the LCD. The LCD is in green. So divide the 12 by the denominator. So we're going to divide this by that 4. So this will turn into 3. So now I've got 9x plus 2 plus 12x. And then this part divides. Now, the first thing people ask me is, well, why didn't that 3 affect this stuff over here? Well, let's erase this a little. Okay, give me a little room to explain to you. Okay, so if we copy this just the top, 3 times 3, x plus 2. Okay. Now, what's in between the second 3 and the x plus 2 is the multiplication. This is multiple, even though it's not written there, it's there. They're not connected. They're not like Siamese twins. Now, over here, if I had something like this, people are comfortable that I could multiply these two and get 24. See, when I multiply these two numbers, it doesn't affect the 4. In the same way, when I multiply these two numbers, it doesn't affect what comes after it. So go ahead and distribute this and solve this problem. Right? Distribute, combine like terms, and then go ahead and solve that problem. So we get 9x plus 18 back. Okay. So we get 21x plus 18. We're going to subtract 18. And get 21x is equal to negative 16. And x is equal to negative 16 divided by 21. All right. So let me give you one to try on your own. So let's try this one. So 3, let's go 2x plus 4 over, let's go 6 minus, is equal to, I should make it something I can't divide into. 3x minus 2 divided by, what's a good number? 8. All right, let's give that puppy a shot. So be sure to do this. Let's find the lowest common denominator. We're going to go 8 is the biggest number. 8, 16, 24, 32, 40. And I go, which is the smallest number that 6 divides into? It's 24. So we'll go 24 times 5. 24 times 4. And now we want to do divisions. So we're going to divide by 4, divide by 8, and we get 20. X plus 4 is equal to 9, x minus 2. And then we're going to distribute. So I get 20x plus 80 equals 9x minus 18. Do that right? 20x plus 80, and then 9x minus 18. Yeah. Okay. So go ahead, keep working on that. So subtract 9x, subtract 80. So I get 11x is equal to minus 98. Like that. Okay. Let's take a picture of this. Okay. Let's just do one more type of problem, and then we'll take a little 10-minute break. So the last problem, and I'll give you time to copy that. I'm just going to write it up here. And let me do this. Okay, now. So my lowest common denominator here is 4. Now the difference between this and that is that we have a fraction in front of our parentheses, but it works exactly the same. So I'm going to multiply this by 4. And then 4. Okay, now just like this one over here, this 4 and this 2 will divide, and then you get 6. Okay, now go ahead and solve that problem. See, you can see that it basically works the same way. This is pretty much the same as this. If you thought of this right here, there we go. Oh, this is my black pen now. There's another black pen. So if we thought of this as 5 over 6, x plus 4, this and this are the same thing. You just bring the 6 over here. So this problem is the same problem as that problem, right? Which is why after we cross out the denominator, we're multiplying these two numbers, just like we multiplied these two numbers. So you can think of this and this as exactly the same thing. So go ahead and finish that. So this turns into 6x plus 18 plus 1. And then when we combine like terms, now this is a variable, so I'm going to get rid of the variable. We get x is equal to 19 divided by minus 2. Okay. So we're going to go over some more different things. Let's take a 10-minute break. We'll go over independent and dependent variables afterwards, and some other we're going to pick up a whole bunch of different concepts. Okay. Okay. Hang in there, everyone. Thank you. Okay. Now, before we go back to independent and dependent variables, or go to independent and dependent variables, let's finish off linear equations with working with inequalities, meaning less than and greater than. So let's clear the decks. Now, in terms of inequalities, there's basically three rules. Three rules of linear inequalities. Now, before we talk about the rules, let's actually write down a problem for linear inequalities. So let's do something like solve 3x, well, let's do something like this. Solve 3x plus 2 is less than equal to 5x minus 7. Okay, so let's look at the three rules. Rule 1, x must be on the left side. So if you have x is less than 3, this is good. If you have 3 is greater than x, this is bad. Okay, so this is okay, this is not okay. So if you have this situation, you have to find a way to switch the variable and the constant, switch places. Okay, let me let people copy that. Okay. 2. If you swap the sign, you have to swap the inequality. Okay, so if A is less than X, then this should turn into A greater than A. So if the number and the variable switch sides, then the inequality flips. Okay. And this is true for less than and also less than or equal to. It's also true for greater than. A is, I'll make this one greater than or equal to. If the constant is on this side and the variable is on that side, then you have to switch it. So the inequality flips. Let me give everyone time to write that down. Okay. So notice over here, x is 3 is greater than x, and then when I wanted x to be on the left side, I flip the inequality. That's why these two are facing the different way. Now 3, put a line there, put a line there. If you divide or multiply both sides by a negative number, flip the inequality. Okay, so just copy that, and I'll show you what that means. Okay. So let's try doing this problem. So I'm going to subtract 5x to both sides. We're going to treat this just like it's an equal sign. We don't have to do anything different than what you would do with an equal sign until we get to the very end. Okay. This is where we have to care. Now, in order to get rid of this -2, I have to divide both sides by a negative number. And when I divide both sides by a negative number, that makes me flip the sign. Flip the inequality. So over here, this is negative. Right, higher. Okay, so over there. Okay, so because we're dividing both sides by a negative number, we're going to flip that inequality, and then we're going to get, by -2 here. We're going to get x is greater than equal to 9/2 like that. Now, from everything that I've seen, I've never seen interval notation. I've seen this notation, so I would probably not bother learning interval notation for this exam. Okay, so go ahead, copy that. Then I'll show you the alternative way of solving this problem. Okay, so this right here is rule 3. Rule 3 over here. Now, these were positive numbers, we would not have flipped them. So let's try solving this in alternative. Oops. So instead of subtracting 5x from both sides, I'm going to subtract 3x from both sides. Okay, I'm allowed to do that. So I'm going to subtract 3x from both sides. Then I'll add the 7, add the 7, and I'll get 9 is less than equal to 2x. Okay, Now, the problem is that the x is on the wrong side. So what I need to do is I need to change sides. Okay. So over here, when we swap sides, we're going to flip the inequality. And this is rule number 2. Okay, so I can either have this situation where the x is on the wrong side, or I can divide by -2. Either way, eventually this inequality is going to get flipped. Now over here, I'm flipping both sides by a positive number, so we don't flip. Okay. Because this is positive, we don't flip. We only flip when this is negative. The reason why we're flipping over here is because the x is on the wrong side. Okay. So let's try one more problem. Move it over here. Okay, go ahead, try that one. So let's subtract 3x, subtract 4. Okay, so now I have 4x is equal as greater than or equal to -16. Okay, so go ahead and make that next step. So this is equal to 4x is greater than or equal to -16. I'm dividing both sides by 4. When I get x is greater than or equal to -4. Now, the reason why I have this example is that you don't flip. The reason why you're dividing by positive numbers. Let's do one more. Line here. So let's try this. So, and then let's go plus 3x. All right, let's go ahead and do that. So do everything you would do that you would do as if there was an equal sign. The only time you have to care about what's going on about flipping is on that very last line, but go ahead and distribute. Everything else is exactly the same. Exactly the same as if you had an equal sign. So let's distribute. Now, what happens is that people get this rule mixed up with distributing. Even though you are distributing with a negative number, you're not introducing multiplication or introducing the division to both sides. It's really that last line that determines whether you flip the inequality or not. You can multiply by negative numbers in the middle of your solving, as long as you didn't introduce those negative numbers, right? It's when you multiply both sides by a negative number or divide both sides with a negative number, like you would over here, that you flip. But if there's a negative multiplication that is already existing in your problem, you don't flip on those. So that's this first step is usually when people make a flipping mistake. Right? So there's no flipping decisions to make over here. Okay. Now let's combine like terms. Okay, now let me make sure I did that right. Okay, that looks good to me. So go ahead, finish this up. So now we go minus x minus x. And then we go minus 5x over 3. And then over here, we're going to divide both sides by a negative number. Okay, now when we do that, that'll make this flip. And then we get x is, oh, that should be a 5. It was a 5, it just doesn't look like a 5. Greater than or equal to, oh, that's negative. Negative 3 over 5. Okay, copy that, and then I want to make sure I get independent dependent variables, because it's one of those concepts that if you get that on the exam, it should be a quick kill. If you know what the words mean, you should be able to determine it very quickly and save, get that one right and save time for other questions. Okay. Now, let's look at independent and dependent variables. Okay. So when you have an experiment, you're going to have two kinds of variables. You're going to have independent variables and you're going to have dependent variables. Okay. Oh, give me 1 second. Pull my plug out. Oh, here we go. That's where it is. Give me 1 second. To fix my computer. Okay. Now, there's a bunch of ways of thinking about the independent variable. When you are graphing it, the independent variable is the x variable, and the dependent variable is the y. The independent variable is what you control. The dependent variable is the outcome. If I'm giving patients different amounts of medication, the different amount of medication is what I control. It's the independent variable. And the outcome, how well or sick they become, that is the dependent variable. Okay. Sometimes people call this the cause, and sometimes this is what people will call this the effect. Because I have the coronavirus, the effect is that I have a hard time breathing. The more coronavirus I have, the more symptoms I have. The more coronavirus I have, the more likely I can infect other people. Okay. So let me give you an example, a type of question that's okay. And then they'll have something like different amounts of water is given to pea plants. The number of peas are measured after 3 months. Okay. So I want you to tell me, what is the independent variable? What is the dependent variable? So when we look at this and we go, what is the experimenter controlling? he's controlling the amount of water. What are we measuring at the end of the experiment? Number of P's. Right, let me give you another one. The size of goldfish are measured after a month putting each fish in a different sized tank. And then just so you know, I also emailed you this morning a worksheet that has a bunch of these. We're just doing a few. So the thing that we measure is the size of the fish. I can't control that. That's what I measure at the end. The thing that I do have control over is the size of the tanks. Oh, shoot, made a mistake. Do that again. Okay. Take a picture of this. Okay, thank you, everyone. Hang in there. Okay, I appreciate everyone working so hard. I'm still available to answer questions. You can just email them to me and say, help me with these TEAS questions, and I'll knock them out for you. Okay. Now, hopefully what will happen is that after the TEAS exam, we could maybe have one or two more of these to like go over some of the questions that you struggled with. So whether CalPERS pays for it or not, after you take your exam, take pictures of everything that you got wrong. And if you're not sure why, send them to me. I'll make a little worksheet and we'll just go over all the mistakes everyone made so that when you take the TEAS for real, you'll feel a lot more confident. Okay? Okay, good
Thank
luck,
you,
everyone.
Professor.
Thank
Thank you.